Hey guys, Avi here, and welcome back to TheCodex. In this video, we're continuing our project, Handwriting Digit Recognition with Python. And in this video, we're going to dive right into getting started with our project. First thing first, we need to go ahead and initialize our very own Jupyter notebook. So I went ahead and CD'd into my directory, Handwriting Digit Recognition. And over here, I'm going to type the line Jupyter and then notebook. And if you go ahead and run this, it will initialize a brand new Jupyter notebook inside of that directory. Now, if you don't have Jupyter installed, what you'd want to go ahead and do is over here, just say pip3 install Jupyter. Or if that command doesn't work, then you want to specify the version of Python you're using, Python 3 for me, -m, pip install Jupyter. And for any package in this video, you'll be installing packages just like this in your terminal browser. So once you've done that, go ahead and create a new Python 3 notebook. And let's go ahead and over here, start off with some very simple imports that will kind of create the groundwork for our project. So we'll be using three main packages. sklearn for logistic regression, for getting our train, test, split function, etc. NumPy for some data analysis, and matplotlib to visualize our digits as we go through this project. So let's go ahead and import all of those. Again, sklearn, matplotlib, and numpy. If you don't have any of those installed, just go ahead and install them right now. Again, the command here, pip3 install matplotlib, pip3 install sklearn, and then pip3 install numpy. So these are our three packages. Hopefully you have all of them installed on your machine already from the last Python and machine learning video. But once you go ahead and do that, let's get our imports sorted out. So we're going to first import from sklearn.datasets. We're going to import a function called fetch_openml. And so I know what you're thinking, what is Openml? Well, let's go ahead and search that up. Openml, what does this show us? It is this website, openml.org. And this essentially is an online repository of a bunch of different data sets that sklearn has a nice kind of piggyback function off of that we can access data sets from. And so today we're using the MNIST digital handwriting kind of data set. And so there are a ton of different resources and articles on this, and this has already been done by a ton of different blogs and articles. But essentially, we want to recognize the handwritten digits of all this entire data set that you can see in this image right over here. So you're going to be given an array of kind of pixel by pixel values of ones and zeros, black and white, and we want to be able to recognize, based on all the input data, what a handwritten image or input number is supposed to be. So this has been done multiple times, and I'm kind of just going over this for the sake of a beginner-friendly project. And here we're fetching from Openml because if I go ahead and search for MNIST and Openml, I'll go ahead and find we're looking for kind of the most popular one here. We're looking for a data set, so let's click data. And we're looking for MNIST_784. So this data set is the one that we'll be using today for our data, and this contains our 70,000 instances of handwritten digits in kind of an array-like format. So very, very kind of fun stuff and allow us to import our data very efficiently. After that, we want to import from sklearn.model selection. We need to import our train_test_split. That will help us in formatting our data for training and testing. Then we need to import our linear regression model. So linear_model, logistic regression model. And then after that, we need to import from sklearn, import metrics. And the reason why we're importing metrics at the very end is because we want to go ahead and create a confusion matrix at the very end to understand how accurate our kind of predictions were on the test data set. Now that we've gotten the sklearn imports out of the way, let's go ahead and add two more. Import numpy as np and import matplotlib.pyplot as plt. Again, very, very standard stuff. We have our 6 imports ready to go. And now, last but not least, at the last end of this kind of cell, just say matplotlib inline. And by doing so, what this will do is our matplotlib graphs will come very nicely in the Jupyter cell format. So first thing first now is to get our data set. And at the very top, we imported the fetch_openml function. What we're going to go ahead and do is create our variable MNIST and set this equal to fetch_openml. And I think you might be able to guess what will go inside of here, the ID of this data set. And the ID here is MNIST_784. So go ahead and just type that right in, MNIST_784. Once that is done, if you go ahead and run this, This might take anywhere from 30 seconds to a couple minutes, and feel free to just, continue on with this video while this loads. But I have a kind of a powerful machine and like a fast data speed, so this doesn't take too long for me, anywhere from 10 to 15 seconds, but we'll give it a second and hopefully it should load in very soon. Awesome. So it just loaded and we now have our data. So if I go ahead and just print it out in this cell, you can kind of see how it's arranged. You have all these pixel values. I think if you looked at the data set, it had 785 different features, 10 classes. So the 10 classes here correspond to the digits 0 to 9. And then last but not least, you have kind of number of missing values and number of instances. Don't worry about these two. So over here, what we're going to go ahead and do is kind of print out what we're dealing with. And so if I go ahead and access our data, this is the raw array format, and get the shape, MNIST.data.shape, this tells us that we have 70,000 kind of digits or handwritten digits, and each one is an array that's 784 kind of pixels long. And so 784 is a 28 by 28 image. And so if I want to go ahead and print out the shape of this, or like the number of labels that I have for this, I can say MNIST.data or .target.shape. And what this will give me is the shape of the labels. So if I print out my target, print MNIST.target, I can see that it's a label corresponding to every single shape. And let's say I print out the first kind of shape in my array. It is an array. And this massive array of 784 numbers corresponds to the image or pixels of my first image. And it says right here in my target that this should be a 5. Okay, very cool. So we just imported our data right here. We got our MNIST data. In the next video, we'll go ahead and visualize this and get ready to apply the train test split function that we imported right over here and create our data. Awesome job, guys, and I will see you in the next video.